this is having a look at the other two things we had to look at last week in terms of the causes of climate change, both physical and human. Now these are massive questions, so we are really cutting down a lot of the information on them and really kind of keeping it quite focused, so that it is more of a zip through. Make sure you kind of check the kind of topics, like the lessons on these, for more information, or the textbook if you need it. So, physical causes of climate change, volcanoes. Now, this is quite a difficult one. There's a diagram there. We'll maybe come to that in a sec. So, how a volcano actually works in terms of its climate change. Let's change this to grey. So, we have our volcano here, and then it starts to explode and put lots of gas up into there. Now, sulfur dioxide is a gas that connects with air molecules really well, and then becomes really dense, and then there's a really good block, so it becomes really thick. So if we've got like that, like our gas coming out from the air, let's go for that. Our sun's up here. What actually happens when a volcano I'll solve these problems. So what happens when we have this sunlight and all this gas is that it actually blocks sunlight out and reflects it backwards. Now this is something called like the albedo. So it creates this idea that the less sunlight is actually getting to the earth. So if we then had a wee plant down here, or let's go a tree, it's getting less sunlight and would then actually cool down and maybe kind of die, as it were. With all this clouds as well, what we bizarrely get is more rain. So these are the major effects of having a volcano. In terms of how that affects climate, is it actually cools down because it's stopping the sunlight from getting in. And a really famous one of this, it was in 1815, and it was one called the Tamboro eruption. Now Tamboro had some massive effects. As this eruption went off, it sent these clouds around the world, and it cooled the climate so much that we actually then got a lot of rain in Europe. And this happened at the same time in 1815 was the Battle of Waterloo. And what happened, Napoleon couldn't use his cannons, so he then ended up, one of the big reasons he lost the battle, because the cannons were bogged down in water. There is a lot more to that. This also meant that, I actually maybe just post an article in Teams, but like it meant that Mary Shelley, who wrote Frankenstein, couldn't leave her house because it was wet all year, so she ended up starting writing science fiction. That we got this idea from A Really White Christmas, also from what was his name, Charles Dickens, when he wrote he wrote Christmas Carol. So all this because volcanoes, a huge volcano erupted in Tamboro in 1815 and blocked out the sunlight and made a general global climate temperature drop of about 3 or 4 degrees. So huge effect from this massive cloud of dust and ash. And the main thing that comes out of this is sulfur dioxide. And it can cause this localized cooling effect. There's a more accurate diagram of really what happens there. That we've got the sunlight's reflected, that infrared heat can't really escape, and we've got general surface cooling that happens when volcanoes, especially really large ones, will happen. Now the other one that is slightly more complicated in terms of the physical climate change causes of climate change is the Milankovitch cycles. So this is where the Earth doesn't quite spin up and down as it is. The axis is a bit more like that through the planet, and then it spins round that way. So as it spins, I'm just waiting on this catching up, as it spins, that we get night and day. So if we didn't turn around, we wouldn't get night and day. However, this axis goes up and down between 20, that's not 23, 22.5 and 24.5. Now, if it's more upright, then the days would be longer, so there'd be more sunlight get to certain areas. It would be warmer at the poles, and if it's further over to the 24.5, you actually get more pronounced day and night, that sometimes it would be longer. So then it'd be colder at the poles. So it'd be colder at the top and bottom for this one. The other big thing we've got is that if we put, this is the sun in the center of our solar system, and this is our planet, that we don't, everyone kind of thinks that, I'm going to wait in this cat, everyone thinks that we go in a circle, like generally we go in a circle, but that's not really true. We actually kind of go more in a elliptical like that, and this changes. So we are talking big years here. This one changes every 40,000 years, and this one changes every 100,000 years. So sometimes we're further away, and naturally if we're further away it's colder, and if we're a bit closer it's going to be warmer. So these two are the big main things that make up the Milankovitch cycles, these natural causes of climate change. However, if we look at the dates we're having, the length of time this takes to occur, is that these are unlikely to be causing the climate change we see now. We've got climate change that's happened fairly quickly over the last 100 years, so it's unlikely to be caused by these two, which a lot of people claim. Equally, for volcanoes, these tend to dissipate after, I mean, the Tomb Raider one had an effect for about 3 to 5 years. So again, didn't have a long scale effect before that actually worked out. So realistically, what we're maybe thinking in is the problem is these ones, the human cause of climate change. Now, unlike the Kahoot quiz, carbon dioxide does come out of cars and has come from burning fossil fuels. I'm really sorry. So that's a really obvious one, and everyone knows where carbon dioxide and fossil fuels come from. The other one that is a big effect is this one. It's methane production, or CH4. Now what happens is when we've got like paddy fields, lots of rice, to create these they basically just like have to bury them in water. But this also creates like a decomposition of natural bacteria, and as natural organisms decompose, they release this gas, which when we're creating paddy fields or rice or lots of products like that, it does create a lot of methane gas. Equally, these guys, kind of cows, oxen, meat production, produce a lot through burps and farts. So they produce a lot of this methane gas. And if we have more of him, the arrow is going to appear as over that person. If we have more of him, what we then need to do is we need to feed him. So we need more rice and more cows. So we need to have more of these cows which produce methane. We need to produce more rice, which causes more methane production as well. So generally a population increase means more methane gas. The other side, so that's very much a cause which happens from our developing world countries as well, where they've got rapidly growing populations, like China and India. Both have got like over 1 billion people in it. The other side is from our types of westernized countries, that we throw away all this rotting food and into landfill sites. And equally, as with rice, decomposing food releases CH4, methane gas. And we are now throwing away in the UK 4.5 million tonnes of food waste in the UK every year. This equates around about 10 billion edible meals. So once the more we throw away, the more methane production is produced. And again, with more people, we actually waste more food. And this isn't even food that's generally gone off. This is food that is still edible by a lot of people. So that's our big one. Right, last one. This one. This is talked quite a lot about. Now, for a little bit of basic biology, for deforestation, that trees take in, I'm going to change the colour because it matches. In fact, let's go with a rainbow. Trees take in carbon dioxide, sunlight and water, and they give us out oxygen, one of the things we need to breathe, and they also give out sugar in terms of like glucose. They also take in some minerals as well. So what they're doing is they're actually doing the reverse of what climate change is, that they're taking in fossil fuels and giving out oxygen. What they also do is they actually, which this diagram doesn't show, they also store CO2. So they store that CO2 inside the trees itself. So they become like something called a carbon sink. Let's go. So this like a carbon store. So when they are then cut down and burnt, which is one of the main ways, a lot of people do go in with like kind of chainsaws, but normally in the Amazon rainforest, the quickest way just to clear a large area of trees is just to burn it down. Some people might remember this from National 5 as slash and burn, which is really useful, but they've used this same technology or this same process to actually clear a lot of the area, and they clear it for, again using your National 5, one of the big things that you clear it for is cattle. So not only are they cutting down trees which have stored carbon and releasing that carbon dioxide back into the atmosphere, they're then replacing it with cattle farming and logging, which is producing more of the CO2, more of the methane, and logging trucks. So it's like a double whammy with deforestation. Not only are they stopping this process from happening, where we take in carbon dioxide and give out oxygen, we're also making this process happen, where we're releasing that carbon dioxide back into the atmosphere, causing the greenhouse effect to take an impact and burn through.